Hello and welcome to this tutorial on scripts, variables and outputs for the GP2 Multifunction Program Editor. This tutorial is from the series Introduction to the GP2 Program Editor. I'm going to give you an overview of scripts, variables and outputs and talk about their uses. We will then implement a simplified ET calculation and I'll also show you how to create a variable for the irrigation control. Okay, so as in the previous tutorials, this one is based on the program that was generated in the previous tutorial on alarms. If you just come from the previous tutorial, please just continue from where you left off. If not, you'll need to import the program. So for the benefit of those that have just jumped into this tutorial, this is how you import it. You click on Edit, Import Program, and you'll need to go to your Delta Link installation folder. Then go to Samples, GP2 Multifunction Program, and you'll select tutorial number 5, which was on alarms. That will import the program ready for this tutorial. To start off with, we're going to be looking at scripts and variables, and they are found towards the bottom of your lists in the overview panel. Scripts contain sequences of instructions which allow you to fully control the GP2's behavior. In the script, you can calculate values and store those in what are called variables. You can also record a variable or a measurement, and you can evaluate conditions and do things based on the outcome of that evaluation. Using these three basic building blocks, you can build up complex scripts that can achieve many different things. Your script can be as simple or as complicated as you like. A few examples of what you could achieve with a script is calculate wind chill, dew point, simplified ET calculations, implement frost prediction, tomato blight, and complex control algorithms such as a PID controller. Some of these scripts you'll find in the samples folder in your Delta Link installation folder. As I just mentioned, scripts make use of variables. Variables are essentially a storage location for calculated values. These are particularly useful for storing intermediate calculation values. Variables can also be used in controls. For example, you could replace a set point with a variable. This will allow you to be able to adjust the set point while the logger is actually running. Variables that are first created in controls, alarms, or scripts are automatically added to the variables list at the bottom of the program in the overview panel. Variables can be recorded within a script, which is useful for logging the outcome of a calculation, for example, wind chill factor. So as you can imagine, we need to get to know variables a little bit better. So what I suggest is that we replace the set point in our control condition to be a variable, thereby allowing us to change its value while the logger is running. So to do that, we'll go to Controls and click on the existing irrigation control. Open up our activation condition, and we can see the condition we previously created. So here the set point is 30. We want to replace that with a variable. So there are two ways of creating a variable in the condition editor. You can either do it by clicking on the variable button and selecting a new variable, which will create a variable named new variable, which you then need to go and rename. Or if you've selected the element as we have here, you can type your variable name directly into your keyboard. So we're going to call this set point irrigation set point. So we've created our first. Now you might notice is that we haven't actually defined an initial value for our variable. That is because we don't do it within the condition editor. That we'll do in the outputs and variables list in the overview panel. So if we click apply, and if we look at the outputs and variables list, you'll notice that our variable irrigation setpoint has now been added to the bottom of the list. If we select the variable and take a look at its properties, you'll notice that there is a variable property called type. So a variable could be one of numerous different types. In this case, it's selected a number, which is correct for our use at the moment. The second option is an integer, which would result in a whole number, so no fraction. And you could also have a time variable or a duration variable. Our initial value we know is 30, so that's what we had previously. And then the following options relate to how the variable is created. We want to be able to edit our variable from the program settings area in the logger window. So to do that, we need to enable it as a program setting. And now since it's going to be shown there, it needs to have a couple of other properties defined, in particular units, minimum, maximum, and a resolution. So we know this is a percentage value because it relates to soil moisture, and its range is correct at 0 to 100 and 0.1 resolution. So the other property over here, chart as a set point, is very useful for the data set, where it will chart it as a hashed line across the chart in which it is useful to be seen. So you can see the soil moisture approach your set point, and then something happens. In this case, irrigation starts. So we'll enable that. So let's apply that and have a look at what's happened. If we go to the logger window, you'll notice that irrigation set point is now available here with initial value of 30%. To edit it, you'll double click it and you can change its value, but we'll leave it at 30 for the moment. So if we start the simulator running, and first we will reset it. So click start. Let it run for a few days. Let's slow it down slightly so it doesn't go crazy. Click on the dataset view, click refresh. And if we have a look at average soil moisture, we'll notice that it never goes down below 30. And in fact, the irrigation relay on the top row is being activated. So the logger is now running. And let's say we've decided actually we need to drop that. 30% is too wet. We want it to be 28%. All you do is you go to the logger tab. You double click on the irrigation set point and you change its value to 28. Click OK, and the logger is still running. So if we perhaps let the logger speed the logger up again slightly, slow it down, and then go and have a look at the dataset, click refresh. You'll see two things in the soil moisture graph. Firstly, we have the hashed line, which is the set point. And as we move further across to the right, you'll notice that the set point has moved down to 28%. And as have the soil moistures have now reached a minimum of 28%. So that's one of the great uses of a variable. So just to reiterate that, the variable in this case is a placeholder or a storage location for what is a number, in this case our set point, and provides a unique way of being able to adjust that value on the fly. So let's now go and look at using a script. So if we delete all the records, so we can edit the program, and we go down to the scripts listed in the overview panel. To add the script, we simply click on it. And as mentioned in the introduction to the tutorial, we're going to implement a simplified ET calculation, in this case the Hargreaves ET calculation. So the formula we're going to be using to calculate the ET is shown now, is what we're going to try and implement in the script editor. Our ET needs to be calculated once a day, and to do that we set the repeat rate of the script to once a day. Let's rename the script to something more sensible. Right, so then to create the script content, we click on the three buttons, which is the edit button, which will bring up the familiar script editor window. Let's make that a little bit wider. Okay, so let's go ahead and implement that calculation. So what we want to do is we want to calculate that value and we want to put it into our variable, into our placeholder, so that we can record it. So before we start implementing that calculation, I'd like to point out to you the numbers that you see over here. Basically those indicate your different steps in the sequence of instructions that you can create in a script. So as we move along, we will create more and more of them. And the gray one is essentially just showing you that you can add one over here. So if we want to now implement that calculation, the first thing we notice is that we need to take that calculation and assign it to a value. So the way we do that is we first select the box over here, which enables these buttons, and we're going to use the assign function because we want to calculate the value and assign it to a variable. The variable we're going to place on the left hand side, and we're going to call that ET Hargreaves. And on the right hand side we add the calculation. So to insert a number, you can just start typing directly into your keyboard. So we're going to add 0.01135, and we hit enter, and we want to multiply that. So we can use the X on the keyboard, or we can click the button over here, and then we want to create some values in brackets, so we add the brackets, and then we want to create a new variable called daily temperature average. And this is another nice way of using variables. Is I know I need to calculate value. I don't want to worry about it quite now, how I'm going to determine that value, but I know we need a value, so we'll just put a variable there for now. And to that we need to add 17.8. Then we move the cursor to the outside of the bracket with this little line which indicates an insert, and we want to add a multiplication, and now we want to add a daily solar average. That will multiply by 0.0864, and then that will divide by 2.45. So these operators you see over here, you can insert using the keyboard representation of that value. So plus minus x divided by or percent sign, or you can always use the plus buttons, the minus buttons. If you need to change value, no problem. You just select it, and you can click F2, or you double click it with the mouse, and it will open up the editor, and you can change its value. You can even change a number to a variable by just selecting it over here or starting to type it, and it will overwrite the currently selected value. Okay, and then once we've calculated that value, we're going to want to record it. So we select the new statement, and we do that, or the new instruction. So we do that by selecting what was the gray box, and we're going to click on the record statement, and what we want to record is the ET Hargreaves. So now we can again type it in if we want to, but because we've already defined it above, we can click the variable drop down over here and just select it, which will save us a bit of time. So now for this calculation to work, we need to define two values, and that is daily temp average and daily solar average. And the way we're going to calculate those is that we're going to totalize them over the duration of a day and then divide it by the number of periods in that day, which will give us the average for the day. And because the script is only running once a day, we need to create another script where we will be totalizing those values. So we click apply over here, and we say we want to add a script. The scripts run in the order that they appear in the list. So because we want to totalize before we calculate the ET, we're going to move it above it. So let's give this a name and call it Totalizer. This we want to have run once every 5 minutes. And then we'll go in and define the totalizers. So again, this is really quite simple. All we're going to do is we're going to create two new variables, call them daily temp and daily solar totals, and we're going to just keep adding the current temperature and the current total radiation to those. So again, we click assign, and then we define the new variables, call them daily temp total, and the value there is equal to itself, daily temp total, plus the current air temperature. And we'll do the same for solar. This makes it a little wider so you can see it. Daily solar total, which is equal to itself plus the current total radiation. And a moment ago you saw that the text in this area went outside of the window, for example like that. And a feature I haven't pointed out to you quite yet is this zoom over here, the zoom feature. So we can actually zoom that in and out depending on what, if we want to squash it into the area or if we see it a bit clearer. So anyway, so now we've created our totalizers, so we're going to apply those. And now in the once a day script, we're going to calculate the average from those totals. So let's go back into the ET calculation. And we want to calculate those values before we do the ET calculation. So the way we insert an instruction above an existing one is by moving the mouse over these numbers, and you'll see there's a horizontal line, and that indicates that it will insert something there. So we click the button and we say we want to add an assign, and we know we're going to have two of them because we need to calculate the average of two values. So in the first one we already defined this variable, daily temp average. That is going to be equal to another variable, which is the daily temp total, which we calculate in the other script, divided by the number of 5-minute periods in a day, which is 288. So again, we'll do the same for solar. So daily solar average equals to daily solar total divided by 288. And then finally, what we need to do at the end of the day, once we've calculated all our values, is we need to reset those totals. Otherwise, they'll just be forever increasing day after day. So we can do that in here as well. So daily temp total equals 0. And daily solar total equals 0. So now we can apply that. So before we actually run that, I'd like to point out that if you scroll down to the bottom here, it's added all the variables that we've used above. And you'll see that ET Hargreaves has a validation error against it, and it's telling us the units are not defined. And the reason the ET Hargreaves variable is doing that is because we're recording it. And if we ever record something, we need to define its units, its resolution, and its min-max range. So if we click on that variable, we can go down here and set its value. So its units are going to be millimeters per day. The other variables have defaulted to something sensible, so we don't have to change those. So let's click apply and see if our ET calculation actually works. So let's restart the simulator. Click the start button. Let it accumulate some data by speeding up the simulator. Let's slow that down. Go have a look at the data set. So now hopefully we'll see an ET series at the bottom of the chart. Yes, there we go, ET Hargreaves, and it is in fact calculating values, and they do look like pretty reasonable values. So then in a few minutes we've managed to create an ET calculation within the GP2. And what's particularly nice about this is that when the logger was designed, we had no idea that this is what we wanted to implement. And now with the use of the script, we can really make the logger a lot more flexible, and you can implement scripts and algorithms and models that we haven't even thought of yet. So what you can achieve with this really is down to your imagination. So one final thing I want to have a look at in this tutorial are the outputs in the outputs and variables list. So let's stop the program, click delete, and go to the program tab, the program window. Go down to the outputs and variables list, and if we click onto one of our relays, you'll notice that they are of type relay. So there are a couple of properties here I'll quickly discuss. The first one of interest is the initial rest state. Basically what this is it defines what the default state of that relay is. And whenever a control, an alarm, or in a script activates the relay, it sets the state of the relay to the opposite of what your rest state is. In other words, your active state. The initial state is applied when you click the apply button on the program. Your logger's relay will be immediately set to its initial state. So for example, you could have a modem connected which you want to be on or powered even if your program is not logging, and that you can achieve by setting your initial state to closed. Just bear in mind when you're controlling that relay that the active state is obviously the opposite of your rest state. So next, shown a sensor tab. This shows the variable in the sensor tab, makes it available, otherwise it's hidden. The next property shows a program setting is particularly useful when you're commissioning a system like an irrigation system, and you want to be able to test that your relays is actually activating a solenoid or a pump, and that the plumbing is all working and not leaking, and it is actually activating the one you think it should be activating. So setting that to true will make it available on the logger tab, and regardless of if the program or the logger is running or not, you can actually turn that relay open and closed. And finally, the persistent property defines whether the logger retains the value or the current state of the relay or variable, in fact, when the logger powers down and powers up again because the battery then gone flat, for example, or there's been a power surge or something to that effect. So that is also quite a useful property to be aware of. Okay, so that concludes the tutorial series for the GP2 multifunction program. I hope you found that all very interesting. Please provide us with feedback if you would like, and we would certainly look at creating other tutorials that might be useful to you. Thanks for having a look at the series, and I hope you've gained a lot of information from them. Thank you for your time, and please visit our website at www.deltat.co.uk.